Hello, my dear students. Welcome to SSC JE 2024 revision series regarding RCC and PSC. My dear, I am P. Somasekhar, faculty at AC Engineering Academy. Today we will see the syllabus, weightage and model questions from SSC JE for 2024. Right. See the first revision series for RCC. Weightage of this subject, it is not fixed, every year it is changing. On an average, you can expect minimum to minimum 10 questions. Coming to the syllabus, it is also important because you can't go beyond the syllabus. RCC design, RCC beams, flexural strength, shear strength, bond strength, then design of singly reinforced and doubly reinforced beams, cantilever beams, then T-beams, lintels, one-way and two-way slabs, isolated footings, reinforced brickworks, columns, staircases, a retaining wall, water tanks. Then given very clearly, RCC design questions may be based on both limit state and working stress method. Right. In few colleges, working stress method is not covered, right? But you take any competitive exam, working stress method will also be given. Even questions are framed based on working stress method. Okay, right. Can see the next preparation strategy. Very important for every subject. You have to know how to prepare. Coming to this subject, first priority you can give for codal specifications because most of the questions given from IS code. Most of the questions given from IS code. After that, there is a chance to give definitions also. After that, more and more chances are there to give based on concepts. So you have to give the priority like this. First, you can give preference to IS codal specifications. Then give priority for definitions. Then come to the concepts. Okay. Next one. IS codal specifications. My dear, better you can take once a screenshot. From this one only you can expect questions from codal specifications. What is minimum cover for beams, slabs, columns and footings? Then minimum area of steel for beams, slabs, columns and footings. Maximum area of steel, minimum diameter and maximum diameter, minimum and maximum spacing, then assumptions, effective span, side face reinforcement, like this. You just take once the screenshot of this slide. Okay. Coming to the definitions, effective depth, singly reinforced beam, doubly reinforced beam, lever arm, characteristic load, etc., etc. Right, you can take screenshot once. Okay, right. Coming to the concepts, types of sections, need of doubly reinforced beams, critical depth of neutral axis, etc., etc. Based on these concepts, they will frame questions. Okay, coming to the first question, I'll give you here few model questions for the examination, right? Come on, first question, if the width of foundation for two equal column loads is restricted, the shape of footing is generally adopted is, options given, A, square, B, triangle, C, trapezoidal, D, rectangle. Very clearly mentioned in the question, width of footing is restricted. When width of footing is restricted, the best one is a rectangular combined footing. Already decided to go for combined footing. Here we have to select the shape, whether it is a rectangle or a trapezoidal. Mostly we use these two shapes. When width is restricted, you can go for a rectangular combined footing. If length is restricted, then you can go for trapezoidal combined footing. Now the correct answer is D, a rectangle. Rectangle, okay? Right. Coming to the next one. As per IS 456-2000, minimum grade of concrete used in coastal area is, my dear, options given: A, M20, B, M25, C, M30, D, M40. Clearly mentioned that coastal area. This IS 456-2000 indicates that RCC. In RCC, what is the minimum grade of concrete? This is the reference code for RCC. What is the minimum grade of concrete used in coastal areas? My dear, it is M30. M30. In general case, minimum grade of concrete used for RCC in general construction is M20. RCC in coastal areas, minimum grade of concrete used is M30. Right? There is a chance to ask this question. Next one. As per IS 456-2000, maximum strain in concrete under axial compression. Options given: A, 0.002, B, 0.0035, C, 0.0035 minus 0.75 times epsilon m. Option D, 0.0003. My dear, one question compulsory based on strain. Here they are asking strain in concrete. Actually, it is the shrinkage strain in concrete. Right? It is strain in concrete under flexure. It is strain in concrete under axial compression and bending moment. It is the strain in concrete under axial compression and bending moment. It is the strain in concrete under axial compression. Under axial compression, strain in concrete is 0.002. There is another one you may expect. Strain in tension steel. Strain in tension steel will be 0.002 plus 0.87 Fy upon Es. There is one more. Strain in compression steel is 0.0035 into 1 minus d dash upon xu or xu max. In this 5, any one you will expect in exam. Axial compressive strain in concrete is 0.002. The correct answer is option A. Here given option B, it is under flexure strain in concrete, maximum strain in concrete under flexure. And the option C given strain in concrete under axial compression and bending moment. And option D given here, shrinkage strain in concrete. Here given additionally to strain in tension steel at the time of failure, 0.002 plus 0.87 Fy upon Es. Another one given here, strain in compression steel. It is 0.0035 into 1 minus d dash upon xu. Okay, right. Another question. Cantilever retaining wall can safely be used for a height not more than. Options given: A, 3 meter, B, 4 meter, C, 5 meter, D 6 meters. My dear, up to 6 meters height, cantilever retaining wall is safe. If you want to use more than 6 meter height, then cantilever retaining wall is not economical. Better you can go for counterfort retaining wall. When height is up to 6 meters, cantilever retaining wall is good. If a height of retaining wall is more than 6 meters, better you can go for counterfort retaining wall. Okay, option D is correct. Next question, ma. With the usual notations, the depth of neutral axis of a balanced section is given by. Here given MC upon T equal to D minus N upon N. Like that, options given A, B, C, D. See here, this question is from working stress method. It is the maximum stress in concrete. C. It is the maximum stress in tension steel. Okay, it is the maximum stress in tension steel. You can write in terms of concrete, T by M. Okay, now join these two. You will get neutral axis. This is the neutral axis and this depth is N. This depth is N and from here to here it is D. Now from here to here it is D minus N. D minus N. Then you can write from similar triangle property. You can write from similar triangle property. How can you write this? It is C by T by M. C by T by M equal to, for a stress C, what is the depth? N. For T by M, what is the depth? D minus N. Now further you can simplify. It is M times C upon T equal to N upon D minus N. From this you can find depth of neutral axis. From this you can find depth of neutral axis for balanced failure, or you can say critical depth of neutral axis can be determined by using this expression. Direct formula they have asked. My dear, option D is correct. For this question, option D is correct. Actually, standard form is like this. I have discussed in notes like this. XC equal to M sigma CBC upon M sigma CBC plus sigma ST into D. Alright. When you simplify this, you will get the same, but in place of sigma CBC, they have given C. In place of sigma ST, they have given T. Right? Okay, now? Fine. When you simplify this, you will get in place of XC, they have given notation N. If you simplify, finally you will get the expression like this. What you will get the expression? Now N is equals to M times C upon M times C plus T into D. You will get this expression. Okay, we don't want actually options given here like this, A, B, C, D. Now the correct option is D for the given question. Okay, right. When earthquake or wind load is taken into account, the permissible stresses in working stress method are increased by. Whenever the structure subjected to wind load or earthquake load, the permissible stresses in concrete and the permissible stresses in steel shall be increased for economical design by 33.33% according to IS code. 33.33%. Option A is correct. Option A is correct. Next question, ma. The factor of safety used for steel and concrete in working stress method, it is important, in working stress method respectively. Actually, working stress method and limit state method, we have two different methods to design the concrete structures. We have two materials. Let us take material. Material is concrete and steel. Two materials we are using mainly in RCC. What is the safety factor used for concrete under working stress method? It is 3. For steel, 1.78, or you can take a round figure 1.8. Okay. Then coming to the limit state method, safety factor used for concrete is 1.5, for steel is 1.15. In these two, you can expect anyone. Here asked working stress method. First, they have asked for steel. Next, concrete. Because here clearly mentioned respectively means order also important. First for steel 1.8. For concrete, safety factor recommended 3. So 1.8 and 3 is the correct answer. Option C is correct. Suppose if they ask limit state method, then which is correct? For steel 1.15, for concrete 1.5. Option A correct if it is limit state method. Okay, right. Next question. In a singly reinforced beam, if the stress in concrete reaches its allowable limit earlier than the steel reaches its allowable value, then the beam section is said to be, my dear, stress in concrete and stress in tension steel. Clearly mentioned in the question, stress in concrete reaches its allowable stress earlier than stress in concrete. It means when it is reached to allowable stress, stress in steel not reached to its allowable stress. First, stress in concrete reached to its allowable stress. Then which section is it? My dear, it is over reinforced section. How can you say? Actually, when area is more, area of steel is more. If area of steel is more, stress in steel moving slowly and the stress in concrete moves at faster rate. Okay, when area of steel is more in the section, the stress in tension steel moving slowly, but the stress in concrete moving at faster rate. As it is moving at faster rate, hence it will reach to its allowable limit first. Okay, right. Here it is over reinforced section. Option C is correct. Option C is correct. Next question. Spacing of stirrups in a rectangular beam is, options given. A, kept constant throughout length. Option B, decreased towards center of the beam. C, increased towards the center of the beam. D, increased at the ends. My dear, if you take general case, simply supported beam subjected to UDL, then shear force diagram looks like this. Here shear force is not constant throughout the length. As shear force is not constant, hence no need to maintain the same spacing throughout the length of the beam. Got it? Shear force is more near the supports. Shear force is less near the midspan. So maintain less spacing. Maintain less spacing. If you maintain less spacing, you will get more number of stirrups. Required more number at the support because shear force is more. Right? Here spacing will be more because shear force will be less. So require less number of stirrups. Okay, na? That means shear force, the spacing is changing. How it is changing? Option B given, decreased towards the center of the beam. No. Decreased means here spacing will be reduced. No. Spacing will be increased. Increased towards the center of the beam. Option D given, increased at the ends. No. No. Option C is correct. It is increased towards the center of the beam. Okay, option C is correct. Spacing of stirrups increases with decrease in shear force. As shear force is decreasing towards the midspan, so you can increase the spacing for stirrups. Option C is correct. Next question. Doubly reinforced beams are preferred. When do you go for a doubly reinforced beam? Options given. A. When the depth is restricted due to headroom, etc. Definitely, when depth is less, obviously concrete area less. As concrete area is less, steel area required more. So, we can split the steel partly into tension zone and partly into compression zone. That's why needed a doubly reinforced beam. Then, when there is a chance for a stress reversal along the length of the beam, definitely we can go for a doubly reinforced beam when the beam is subjected to reversal of stresses. True. C. Beam subjected to impact loads. Definitely, impact load is a shock load. Concrete alone cannot resist the shock load. So, we have to go for design of doubly reinforced beam. Option D, all above. Yes, in all the cases, we can choose a doubly reinforced beam. Option D is correct. Next question. The stress strain curve of the concrete as per IS 456-2000 is, options given. A perfect straight line up to failure. B. Straight line up to 0.002 strain value and then parabolic up to failure. C. Parabolic up to 0.002 strain value and then uniform up to failure. Option D given, linear up to 0.002 strain and uniform up to failure. Actually, for a design purpose, the stress strain curve of concrete recommended by IS code is parabola up to 0.002 strain, then uniform or constant till failure. Concrete will fail at this strain. Okay, it is parabola up to 0.002 strain. Here given a perfect straight line, A wrong. Then linear up to, wrong. Then given option B, straight line up to, wrong. Then only one option is there, that is option C. Sometimes elimination technique also helps to pick up the option very quickly. We can save the time. Okay, right. This is strain axis, this is stress axis. Next question, ma. A simply supported beam is said to be a deep beam if the effective span to overall depth of beam is less than. Whether it is a normal beam or a deep beam is decided based on span to depth ratio. If span to depth ratio is not greater than 2 for a simply supported beam, then it is a deep beam. If span to overall depth ratio not greater than 2.5 for a continuous beam, then it is a deep beam. Okay, L by D ratio not greater than 2 means less than 2 or equal to 2, right? Here they asked less than 2, option A. Clearly mentioned simply supported beam, right? Okay. Next question. In a simply supported slab, alternate bars are curtailed at, options given, 1/4 of the span, B 1/5 of the span, C 1/6 of the span, D 1/7 of the span. My dear, alternate bars are curtailed Alternate bars are curtailed at 0.15 L from center of the support at 0.15 L. Either you can curtail or you can provide bent up bars, nothing wrong. 0.15 L means L by 7. Either you can say 0.15 L or you can say L by 7. It is 1/7 of the span. Option D is correct. Option D is correct. Okay. Next question. For steel of grade Fe415, the value of XU max upon D given options A 0.42, B 0.46, C 0.48, D 0.53. When calculator not permitted into examination hall, then solving this one is a difficult. 0.0035 upon 0.0055 plus 0.87 Fy upon ES into D. If you try for Fe250 grade steel, Fy is 250. ES value it is constant 2 into 10 to the power of 5. Then simplify within the brackets, you will get 0.53D. It is for Fe250 grade steel. XU max equal to 0.48D for Fe415 grade steel. XU max equal to 0.46D for Fe500 grade steel. It is better to remember these values because simplification in the examination hall is not easy. It will be time taking. So, here given Fe415 grade steel. For Fe415 grade steel, XU max equal to 0.48D. Now, send D this side. You will get XU max upon D, which is equal to 0.48. Option C is correct. Next question. Side face reinforcement is provided in a beam when the depth of web exceed 750 mm, when member is subjected to flexor. You can provide side face reinforcement. When depth of web is more than 450 mm, when member is subjected to torsion, provide the side face reinforcement. When depth of web is more than 500 mm, if the member is made of prestressed concrete. 3 situations. In the 3 situations, we can go for side face reinforcement. Here you check it. Side face reinforcement is provided in a beam when the depth of web exceeds. They did not talk about flexor. They did not talk about torsion. They did not talk about prestressed concrete. Nothing is mentioned. Simply they asked, when do we provide the side face reinforcement? Right? If nothing mentioned, you have to consider general case. General case is when member is subjected to only flexor. So, option D is correct. If member is subjected to torsion, 100% they will give in question. If it is a prestressed concrete member, 100% it will give in question. But prestressed concrete is not given in syllabus, but rarely they are asking questions, 1 or 2 questions, simple questions they are touching. Right. Come on. Next one. If the length of a wall on either side of a lintel opening is kept at least half of its effective span L, the load W carried by the lintel is equal to the weight of brickwork contained in an equilateral triangle, producing a maximum bending moment. This is the triangular loading. Triangular loading is W. Okay. Now this W is split. This side W by 2. Even this side also it is W by 2. Now take it here. it is W by 2, it is W by 2, right, at L by 3, L by 3, L by 3. Now reactions are W by 2, W by 2. Now maximum bending moment is W by 2 into L by 3, WL by 6. Maximum bending moment you will get WL by 6. If it is the triangular load distributed over to the lintel, the total load is split into two equal halves, W by 2, W by 2. These loads are acting at the centroid of the triangle. So finally, if you make it into a beam which is acting at L by 3, L by 3, L by 3. Now take the moment from the reaction W by 2 into L by 3, WL by 6, W by 2 into L by 3, WL by 6, right? Okay, fine. So WL by 6 is the maximum bending moment here. Okay, right. Next question. The area of minimum tension reinforcement provided in beams as per IS 456-2000 is options given. A. AS upon BD equals to 0.85 upon Fi. B. ASV upon B into SV equal to 0.4 upon 0.87 Fi. Option C, 0.8% of gross cross-sectional area. Option D, 0.12% of BD. My dear, this 0.12% of BD is the minimum steel in slab. Minimum steel in slabs. If HYST bars used, if HYST bars used, okay, 0.8% of gross cross-sectional area. This is the minimum longitudinal steel in a column. Minimum longitudinal steel in a column. ASV upon BSV equal to 0.4 upon 0.87 Fi. It is the minimum shear reinforcement in beams. Minimum shear reinforcement. Minimum shear reinforcement in beams. But the question is minimum tension reinforcement in beams. Option A is correct. If they asked minimum shear reinforcement, option B correct. If they asked minimum steel in columns, option C correct. If they asked minimum steel in slabs for HYST bars, option D correct. Anyway, for the given question, option A is correct. Okay, right. Next question. Long and short spans of a two-way slab are IX and IY, or LX and LY. And the load on the slab acting on strips parallel to LX and LY be the WX and WY respectively. According to Rankine-Grashof theory, what's the relation between this? Okay. See, my dear, it is the slab. Here we have to consider one strip at the middle parallel to the longer span. Right here, longer span is what? Long. This is LX. Short span LY. Okay. Parallel to the what is that? Shorter span. One strip I have considered at the middle or at the center. Right. At this point, I am talking about at this point. Okay. At this point, deflection is same. Deflection is same. Okay. Now take the deflection here. 5 by 384 into Wx into Lx to the power of 4 upon EI. Here 5 by 384 into Wy into Ly to the power of 4. Longer span is Lx, this is Lx, this is Ly, okay, upon EI. Now 5 by 384 cancel, EI gets cancelled. What is Wx upon Wy? Wx upon Wy is equals to Lx upon Ly whole to the power of 4. Whole to the power of 4. Okay, na? Clear? So, option D is correct. Here notations they have given like that. Okay, don't worry. Option D is correct. Next question. The maximum area of tension reinforcement in beams, very clearly mentioned. Maximum area of tension reinforcement in beams is, options given: A 2%, B 4%, C 6%, D 8%. Actually, in beams, we can provide tension steel as well as compression steel. Maximum tension steel should not be more than 4% of gross cross-sectional area. Even maximum compression steel should not be more than 4% of gross cross-sectional area. In slabs, maximum steel should not be more than 4% of gross cross-sectional area. In columns, maximum steel should not be more than 6% of gross cross-sectional area. Important. In footings, it is same as that of slabs. It is same as that of slabs. Here clearly asked maximum steel, that too in beams, in tension zone. 4% is the correct answer. 4%, right? Okay. Next question. The main reinforcement to be provided in a cantilever beam is at, options given: bottom, top, neutral axis, anywhere in the beam. Okay, you can take cantilever beam here. You take a cantilever beam. When cantilever beam is subjected to loading, when cantilever beam is subjected to loads, just apply the load. Under the load, the cantilever beam will bend. So, this is hogging curvature. This is hogging curvature. In hogging curvature, tension will develop above the axis and compression will develop below the axis. This is the axis of the member. So, tension is developing above the longitudinal axis. So, we can provide the reinforcement in cantilever beam at the top because tension is developing at the top. Okay, right. Option B is correct for this question. Option B correct. If they asked simply supported, then option A correct, because in simply supported beams, tension will develop below the axis, compression will develop above the axis. For cantilever, opposite. Tension will develop at the top and compression develop at bottom. Next question. The distance between extreme compression fiber and the centroid of tension steel is, options given: A overall depth, B effective depth, C lever arm, D width. Okay, suppose if you take the beam, it is a width. It is a width. Okay, right. Then it is a steel reinforcement in tension zone. It is overall depth of the beam. Overall depth is measured from where to where? For example, if I take this is neutral axis, it is compression, it is a tension. Now it is overall depth, right? From extreme compression phase to till extreme tension phase, whatever the distance available, that is overall depth. What is effective depth? Effective depth is from extreme compression phase to till centroid of tension steel only. Then what is lever arm? See, it is the tensile force, it is the compressive force. Now the distance between compressive force and tensile force is lever arm. This is overall depth, this is effective depth, this is the lever arm, and this is the width. Here they have given distance between extreme compression fiber and centroid of tension steel. This is effective depth. Effective depth. Okay. Right. Next question, ma. The diameter of transverse reinforcement of columns should be equal to 1/4 of the diameter of the main steel rods, but not less than. Options given: 4 mm, 5 mm, 6 mm and 8 mm. According to the recommendations of IS code, one-fourth of the diameter of main steel or 6 mm, whichever is maximum. The diameter of transverse steel in column is 1/4 of diameter of main steel or 6 mm, whichever is maximum. Okay. Option C is correct. Next question. Okay, before I am going to the next question, my dear, ACE is conducting mock test on 26th May, timings 1 p.m. to 3 p.m. my dear, which is online mode only. It is for civil, mechanical as well as EEE. My dear, if you write the test, you come to know the reality, where you stands. You can feel it like a real time, how you write the exam. In the same way you can feel it. So, better once you can take the test series. I think its cost also very less. It is around 100 rupees. It is very nominal fees, very nominal fees. Okay. Just to help the students, to provide awareness, to write more and more number of students, they have given fees only 100 rupees. Better you can take once test series. Okay. Right, my dear. Next. A doubly reinforced beam is considered less economical because options given: A, tensile steel required is more than that of a balance section; B, compressive steel is under stress; C, shear reinforcement is more; D, concrete is not stressed to its full value. My dear, compressive steel is under stressed. That's why doubly reinforced beams are considered as less economical as compared to singly reinforced beams. In compression zone, concrete is stressed to its maximum value, but compression steel is not stressed to its full value. That's why it is considered as less economical. Next question. Yeah, another good question. If P is the net upward pressure on a square footing of side B, you can take the footing, square footing. Its side is B. Side is B. Okay. For a square column of side a square column is resting over the footing. The maximum bending moment is given by, my dear, if you want to find the bending moment, first of all you have to know the critical section location. For bending moment, the critical section lies exactly at the face of the column. Now you can take this area, right. Tell me, what is this area? This one is from here to here. What is this? It is small b up to center b by 2. It is coincide with a by 2. So from here to here a by 2. From here to here small b by 2 minus a by 2. Okay, what is this one? B. This one is b by 2 minus a by 2. Now this area will be b into b by 2 minus a by 2. This area. Now area into pressure will give the force. Now force into perpendicular distance will give the moment. Centroid will be half of this, half of b by 2 half of B by 2 minus small a by 2. My dear, simplify this. PB, 2 take out, 2 take out, 2 take out, 8 into B minus A into B minus A whole square. PB by 8 into B minus A whole square. Option D is correct. Okay na? Right. If you know where is the critical section, then easily you can find out. Right. Because this part is looking like a cantilever. When cantilever subjected to UDL, however you find the moment, in the same way you can find out. Okay. Right. Next question, ma. What is the assumption in the steel beam theory of doubly reinforced beams? Only steel bars will resist tension, only concrete resist tension, stress in tension steel equal to stress in compression steel, both concrete and steel will resist the compression. According to steel beam theory, there is an assumption that stress in tension steel must be equal to stress in compression steel. Option C is correct. Okay. Next question. As per IS 456-2000, the effective width of flange for a T-beam is, my dear, here given formulas, effective width of flange for a T-beam they are asking. It is effective width of flange for isolated L-beam. For isolated L-beam, effective width of flange formula. And this is the formula for isolated T-beam. For isolated T-beam, effective width of flange formula. And it is for L-beam. For L-beam, effective width of flange formula. And it is for T-beam. For a T-beam, effective width of flange formula. They are asking simply for a T-beam, not for isolated T-beam. Option A is correct. Next question. Minimum time period for vertical formwork to columns. My dear, 24 hours. 24 hours sufficient to remove the formwork, vertical formwork to the columns. 1 day or 24 hours. Next. A T-beam behaves as a rectangular beam of width equal to its flange if it's a neutral axis. My dear, whenever neutral axis lies within the flange, neutral axis lies within the flange, then you can treat it like a rectangular section. Though it is a flanged section, but for analysis and design, you can treat it like a rectangular section. Here question is, a flanged section can be treated like a rectangular section, then where is the neutral axis? The neutral axis lies within the flange, remains within the flange. Option C is correct. Next question. An RCC beam of 200 mm by 300 mm effective is subjected to a factored shear force of 30 kN. The maximum nominal shear stress in Newton per mm square as per present code is, they are asking nominal shear stress. What is the formula for nominal shear stress? Simply it is Vu upon Vd. Vu given here 30 kilonewton, you can write 30 into 10 cubed upon Bd, where B is 200 and D is how much? 300. Simple. How many zeros are there in numerator? 3, 1, 4 zeros. Denominator 2, 2, 4 zeros. 4 zeros, 4 zeros gone. 3, 3 gone. 1 by 2. 1 by 2 equals to 0.5. 0.5 Newton per mm square. Option A is correct. Okay, na? Right. See, very simple questions. Only thing is that you have to write down in short notes definitions and simple formulas. Mostly they will ask formulas or definitions or direct codal specifications they will ask. Okay. Come on, next question. If the nominal shear stress tau V at a section does not exceed the permissible shear stress, means tau V should not be greater than tau C. If it is the case, then section is safe in shear. Though it is safe in shear, but still we have to provide minimum shear reinforcement. Options given here, minimum shear reinforcement is still provided. Yes, option A itself correct. Next question. The permissible shear stress in concrete for beams without shear reinforcement, it is important. Without shear reinforcement depends upon, actually we have two shear limits. One is a tau C, another one is tau C max. Tau C is measured without stirrups. Tau C max is taken with stirrups. Here tau C depends on two things: concrete grade and percentage of tension steel. Tau C max depends on only concrete grade. Tau C max depends on only concrete grade. Here without shear reinforcement, it means it is a tau C only. So it depends on both. The maximum spacing of vertical stirrups in a beam as per IS 456-2000, options given here. According to IS 456-2000, the maximum spacing for vertical stirrups will be 0.75 D or 300 mm, whichever is smaller. Option A is correct. Next, the lap length in compression is not less than, my dear, it is the lap length in flexural tension or bending tension. It is the lap length in direct tension. And it is the lap length required in compression according to IS code. You must join the bars. Okay. This length they are asking. What will be the length of the joint required? It depends where you are providing this joint. In flexural tension zone, then lap length will be LD or 30 times bar diameter. You are joining the bars in direct tension zone, then lap length will be 2 times LD or 30 times bar diameter. If you are joining the bars in compression zone, then lap length will be LD or 24 times bar diameter. Okay, right, option C correct, because they asked in compression. For full anchorage, the stirrups should extend by a length of dash times the diameter of the bar when bent at 135 degrees. Options given: A, 4 times bar dia, B, 8 times dia, C, 12 times dia, D, 6 times dia. Here important thing is, for a tension steel, if it is 45 degrees bend, 4 times dia. If it is 90 degrees bend, 8 times dia. If it is 135 degrees bend, 12 times dia. If it is 180 degrees bend, 16 times dia. It is for tension steel. For stirrups, this value not recommended 45 degrees. For 45 degrees bend. For 90 degrees bend, 8 times dia. For 135 degrees bend, 6 times dia. For 180 degrees bend, 4 times dia. Clearly mentioned that stirrups, angle of bend given that 135 degrees. For 135 degrees, for stirrups, it is 6 times bar diameter. Option D is correct. For a tension steel, angle of the bend or anchorage value. For stirrups, anchorage value. Okay, right. Which one of the following statements is correct? In a reinforced concrete member, the best way to ensure adequate bond is, my dear, if section is not safe in bond, the best option is selecting smaller diameter. without changing total steel, select the smaller diameter than design diameter such that you will get more in number. Use smaller dia, more in number without changing total steel. Here they have given option A to provide minimum number of large diameter. No. To provide large number of smaller diameter. Yes. It is the best way to adequate the bond. Right. Next question. Equivalent shear force for beams. It is a direct formula. VU plus 1.6 TU upon B. Equivalent shear force formula. As per IS 456-2000, minimum area of steel in slabs, if mild steel is used, if use mild steel in slabs, 0.15%. If use HYST bars, 0.12% of BD. Okay. Next question. The maximum spacing of main reinforcement in slabs as per IS 456-2000 is, for main reinforcement, it is 3D or 300 mm, whichever is smaller. If it is a distribution steel, 5D or 300 mm, whichever is smaller. But clearly mentioned, it is for main reinforcement. If it is a distribution steel, option C correct. But here given main steel, so option A correct. 3D or 300 mm, where D is the effective depth of the slab. Right. Next question. The reduction coefficient of a reinforced concrete column with an effective length of 4.8 meter and size 250 by 500 mm square is, they are asking reduction coefficient CR equals to 1.25 minus L upon 48 times B. That is 1.25 minus effective length of column given here 4.8 meters. You can write 4800 upon 48 times B given 250. B given 250. Right. Now 48 ones are 48 hundreds are. So 0, 0. Now 5 twos are 5 fives are. So 0.4. You will get 0.85. After simplification, you will get 0.85. They are asking reduction coefficient. This is a direct formula recommended by IS code used for long columns under working stress method. To estimate the load carrying capacity, we can use CR. Next question. As per IS 456-2000, maximum diameter of steel bar used in slabs. Maximum diameter of steel bar used in slabs should not be more than 1/8 of overall thickness of slab. D is the overall thickness of slab. Maximum diameter should not be more than 1/8 of overall thickness of the slab. Option C. Next question. The minimum thickness of a flat slab required according to IS 456-2000 is, minimum thickness of flat slab according to IS code is 125 mm. Next, torsional reinforcement in two-way restrained slab required for a corner with two continuous edges. At any corner, if both edges are continuous, then no need of providing torsion reinforcement, not required, because net torsional moment becomes 0. Okay. Next question. The permissible value of deflection for a two-way simply supported slab with a shorter span less than 3.5 meter and the live load is less than 3 kN per meter square using deformed bars. What is the L by D ratio? L by D ratio, right? It is a two-way slab. It is two-way slab. The two simply supported. L by D equals to, my dear, 35. For mild steel, if you want for HYST bar, multiply with 0.8. So, you will get 28. Option B is correct. Option B is correct. Okay? Right. Next question. The minimum number of bars in a circular RC column as per IS 456-2000 is, minimum number of bars in a circular column 6, in a rectangular column 4. Okay. Next question. An axially loaded column is of 300 mm and square in section. The effective length of the column is 3 meter. What is the minimum eccentricity? Minimum eccentricity will be unsupported length of column upon 500 plus lateral dimension upon 30 or 20 mm or 20 mm, whichever is maximum. Whichever is maximum. Here unsupported length not given, given that effective length, but support conditions not given. If support conditions not given, you can use effective length as the unsupported length. So it is 3 meters, write in mm, 3000 upon 500 plus B is 300 mm, 300 by 10. If you simplify, you will get 16 mm. Now compare with the 20 mm. Compare this, it is more, 16 mm, 20 mm, this is more. So therefore, E minimum equals to 20 mm. Minimum eccentricity will be 20 mm. Option D is correct. I hope you will understand how the questions there will be a chance to ask in exam. Almost in this model, like this type of questions you can expect in exam, right? Due to time constraint, my dear, I am not able to give a few more questions, okay? Anyway, I wish you all the best. I wish you all the best, okay?